All right. So our goal is to first come up with returns as we use them during the last couple of classes. Where did these come from? Okay, so we're going to focus on stock returns. I'm not going to teach you how to get an S&P 500 index return. Okay, it's a little more complicated. But the first step to getting that would be to get an estimate of returns on stock. So here we begin. We're going to work with historic data first, so ex post returns, and talk about how or what is a dollar return on a share. If it's a dividend paying stock, so investors will get a portion for every dollar invested, they will get, or let's see, if I just talk about the dollar return to holding a share, okay? So this is the dividend. This represents the dividend that they'll get. So that's 35 cents, $35, depends on the value of the stock, okay? And they'll also get something else. What's the something else? It says there in words, but anyone want to explain that to me? And also these subscripts here. So this at any period in time, the dollar return, and I can put a subscript here as well. I could say it's the subscript at time t, and time t would be, you can think of t as a point in time, so time t, or you can say today, or you could say now to think about t, because the other subscripts are relative to t. So we got to position ourselves. So t, dollar return today, is equal to the dollar dividend today plus something else. Anyone want to tell me what the something else is? What does it say there?
Dollar return.
No, the dollar return is equal to the dollar dividend plus something else. What's the something else?
Oh, a change in market value.
Right. So remember when we talked about the opportunity cost? Opportunity cost. You have to think about what something is worth according to what the market sees that it's worth, right? So I'm holding a share of a company and I'm going to earn, if I've held it long enough, we'll just presume I earn this dollar dividend. And then I'm holding an asset that's gone up in market value. So I experience that as a return. So the change in market value, the price today minus the original price or the price last period gives me a boost, gives me a return. Now, I'm not selling it. I'm not going to realize that dollar. Oh, I'm getting feedback. I'm not realizing that unless I sell it, but still, that's how we I acknowledge the return over that period. I could sell it in the instant, right? And get that, realize that return. All right. Next step is I want to turn this into a percentage. So I want to turn this into a percentage. Oh, let me make one last point. There might not be a dividend, right? And then the dollar return will just be based on the change in market value. But okay, so I want to turn this into a percentage. So I need to think about, this amount relative to what, right? So I'm going to use the beginning market value. So this is the percentage return relative to the beginning market value. That looks like this. This is the formula on the top. And then I'm going to divide by the original market value. Is everybody okay with that? I'm going to call that the return at time t, or the return today.
Ah, mira.
And then
Yes, yes.
I can think of this as
Oh, oh.
for every, well, so RT is also represented in this alternate way, in this interpretation. I can split it up into the dividend yield. So this is the dividend relative to the original price, and we call that the dividend yield. And then this portion is known as the capital gains yield, right? So this is what I make um, as a result of the change in market value relative to the original price. And another reason to divide this up is because investors will pay, they could have different tax rates for dividend yield and capital gains yield. So that's a common formula. And that's just based on this original one. You could also write it like this. I can see that I can separate these, so drop the bracket, and then these minus 1. And this gives me an idea. If you remember um, our returns, or sorry, our interest rates, when we would calculate interest rates or interest rate conversions, right? We'd always minus the 1, because what we really want to see is the for every dollar invested, are we getting, what are we getting? This portion isolated shows if you're getting more than $1 back. So mostly we used this version, or this version of the formula in this class. So this is the data we're headed for. And I want to say a few things. But let's get back to this. First, I want to start here. Let's do an exercise. Let me get the formula for you, and we will calculate returns. I will get this. There. Not here. Oh, here. I'll leave this here. And then here. Okay, so try this problem. Suppose a stock had an initial price of $42 per share, paid a dividend of 84 cents per share, and had an ending price of $46.20 per share. So given that information, what do we have? What is this? $42.
PT -1.
So calculate the dividend yield and the capital gains yield. What do you get?
I got 0.12.
Right. So what is that? 12%.
12%.
So you just found out the estimate of the return to the stock. Notice this is just a moment in time, right? It's changing. That's why we refer to this as T, and then next period we calculate it again, and it'll be different, and we'll talk about what to do with that because these are just estimates at a point in time, or calculations at a point in time. So what is the dividend yield then? The dividend yield would just be the first part. And the capital gains yield is the second part. So which one is higher?
Capital yield.
Yeah. The change in market value is a larger component of the total return. So investors could just not receive dividends. The company could be reinvesting profits rather than paying dividends, and investors stand by the firm because they experience their capital gains yield and they're content. They don't pay taxes on the capital gains yield until they sell their stock. Is a point to make. All right. Can I move on? So in the end, you've got 12% there, and it divides into 2% and 10%. I don't know why I wrote that. Sorry. December that. Let me know if I make typos. Okay, I'm moving on. Okay, so then what? So we have, if we calculated each one of these at different points in time, just like I showed you, what would it say about what is what could we say? Like there's quite a bit of variation there, but we could come up with an estimate of what was the average return, right? What's a representation of the returns over this period. Before I go there, though, I want to talk about the formula a little bit more in here. Okay, so regarding the percentage return, percentage change, the percentage change, capital gains yield is this idea of taking the new value minusing the original value, dividing by the original value. Another way to refer to this is percentage change. You might have seen this in your economics class or in other finance classes. Okay. And I'm going to show you that this is a general formula for return, but you've seen it before. If I take this general formula and I impose restrictions on it or assumptions on it, I get something I've seen before. So this is the formula here. Let me erase this because it's a lot going on. Let me erase this. So this is the formula here that I divided into the dividend yield and capital gains yield. And if I think about dividends being constant, instead of DT, I could call that C1 because the next dividend I have to wait a period to get that, right? So I'll call that C1. Actually, maybe I'll use another color. I'll use red for this. And I'm going to refer to the original price as one period before that constant dividend. That's the original price. And I look at this, I observe this percent change as constant. If there's a constant percent change, in other words, a constant growth rate, oh, I have to write down my assumptions. Let me go back here. So dividend constant, first dividend, one period from valuation. This should start sounding familiar. Three, constant growth rate. Oh, I made, it's not dividends constant, sorry. Dividends grow at a constant rate. Let me put that together. It's not dividends constant. Always making dividends grow at constant rate is my assumption. So the dividends grow at a constant rate, and the first dividend one period from valuation. Then this portion is just G. If I make those assumptions, then I can estimate the return. So this is a formula for every period, but by doing this, I'm going to get an estimate for the interest rate over the period that this happens that looks like this. I'm going to call this I, the interest or the return, the required rate of return, all those words we have for I can rearrange it. Depends what you want. In this case, I wanted to estimate the return. So that's what I did. I'm going to call it I and remember where that comes from. This is the formula for growing perpetuity. Or perpetuity with growth. So it's a more general, this formula that I taught you today is a more general formula with restrictions on it. You can see that we've been using a variation of this formula all along. Okay, I don't know if you see it very well right now, but you can look at this and validate that, okay? So when we calculated perpetuity with growth and valued it, we were using given information. I gave you C1, I gave you I, and I gave you G um, as an estimate or as a statement from the firm that they anticipate certain level of growth. So we were able to make this form or calculate this formula. In this case, this is observing the market, knowing the original price, knowing what that initial dividend is, and following any prospectus of what the growth of the company is going to be, growth rate, you can estimate I. Okay, so it's different information that you'd use to calculate the discount rate here. And all I'm trying to say is, in fact, with those assumptions, you have a special case of the more general formula, this one here. Okay, so you've seen this before, but our focus is not finding the price. Our focus is going to be finding the return. Okay, any questions about that? This has a name. In this form, estimating the discount rate using assumptions or using information that allows you or permits you to estimate G, you would calculate the discount rate this way, all right? This is known as the dividend growth model. So when I refer to the dividend growth model as a way to estimate the return, that's like my initial introduction into estimating the discount rate for this security. So this would be for a firm finding the discount rate using the dividend growth model. You use this variation of the perpetuity with growth formula that essentially comes from the broader or more general formula for return with assumptions. Okay, so I'll say that's the first model that you've kind of known, but I'm putting a label on it. Okay, so I'll refer to this as model 1. Well, I'll put it over there because you're going to get confused which one is model 1. Model 1. And I'll refer to it as the dividend growth model. Essentially, there's 3 ways that I'm going to show you to estimate a discount rate. So that's the first way. The second way is to use some statistics. So here are 3 different statistics you could use to take data like this and estimate returns from it. I'm going to give you different data, but just to keep in mind that what I'm talking about and what the purpose is. I'll put it, that didn't work. Okay, so data like this. Let's say I want an estimate of the return over the period that I've been given the data. So for every dollar invested after time T, big T, how much did I earn for every dollar invested? So this would be a holding period return. And the way you calculate the holding period return is with these accumulation factors, right? One plus the rate, one plus the rate. Now we've seen this before, but I'm changing the rate of return now. The rate of return changes just like this changes, you see? And then I have to minus one, just like the way we're used to. We want to look at per dollar, right? We want to say per dollar invested, what's the return? So in that spirit, this is how you calculate the return. Now, I don't want you to do it for this data. I'm going to give you a new data set. I'm just using this to reference what it is I'm talking about. Okay. So that gives you the return over a period of time. But what if you want an average return over that period of time, or an idea of per year or per period return? There are two options: the geometric average return and the arithmetic average return. The geometric average return stays with the idea of these factors, these accumulation factors that we got here. Essentially, I'm using the holding period return rate. I'm taking a fraction of it in the powers. Remember, when we do effective rate calculations, we partition, or we put the division in the exponents, right? Because this is a power effect. So that keeps track of the compounding effect. And then I minus the one. So you can write it like this, you can write it like this. So it's taking the holding period return, add the one back, and take the square root, or sorry, the teeth root of this amount minus one. And we're going to practice this in a moment with a new set of data, but I'm just going to review the last one. So the alternative is that I take them all and just take the average of the returns to get a measure of the average return, what happened per period. Add them up and divide by how many there are. All right, so what's the difference between geometric average return and arithmetic average return? What's the same? What's different between them? Do you know? Besides the calculation, obviously it's different. Well, you'll get a different number sometimes. Sometimes you'll get a very similar number. Anybody know what the difference is?
Does it have to do with like the weight of each percentage? Because like I know in investing, like if you have like $100 and if it goes down 50%, well, it needs to be more to go back up to the original 100. It's not the same.
And so your answer was, what did you say? Because it's a different weight?
Yeah, like the weight it has on the percentage. So like
Okay, so mhm.
if it goes like 100% and then it gets cut in half by 50, like it drops 50%, it's 50, but it needs like 100% of 50 is 25, so it won't be 100, it will be 75. So like
Okay.
I don't
Okay,
know.
yeah, something like that. You know, though you're on the right track. Basically, what's going to happen is um you'll calculate them both. Let's just say it that way, okay? So you'd calculate them both. If there is a difference, the better one is the geometric average return, okay? And that's because the arithmetic average return, or averages, suffer from being influenced by extreme values. So these are they are very sensitive to outlier values that will misrepresent the general pattern of data. And I talk about that in the review that I gave you. Not in the review in class, but the statistics review. I put videos and documents in, and I talked about that. So the rule is if these are different, compute both. Okay. GAR is not sensitive to outliers, to extreme values. Remember that the mean has to balance, it's a center of gravity, has to balance all of the data. That's its characteristic. And by doing, so it will move towards those extreme values and be a little more distorted as the representative of the data. So often we use a median instead of an average when that happens. Well, when it comes to rates of rates, we use a geometric average return as opposed to a median, but you could also check the median and see what that's like. But we don't talk about that here. Just because of the factorial effect of rates, the, the idea of the compounding, accumulation factor effect. So this says compute both. If different, use GAR. All right, so we're going to practice making these calculations, and we're going to do it with this set of data here. The question is, as a result of the financial crisis in 2008, did the market recover by 2010? Here are actually the returns estimated, or actually I got this data from the internet. This is the calculation of the S&P 500 index throughout the period from 2007 to 2010. So you can see it's quite wild, right? From 5.49%, which is rather low, but then to a cliff. It fell off the cliff at negative 37%. So what does this mean? It means for every dollar invested, investors lost in that year 37 cents. Oh, this is a negative. So this is going to be, yeah, they lost it. So then it picked up. And then, so this is quite wild as well, correction. And then settled at 15. So looking at these numbers just like that, did the market recover? How can we put these numbers together? Let's calculate the holding period return, the GAR, and the arithmetic average to see what the answer to that question is. So here are the formula. I'll give you a moment to try and compute them so you can become familiar with them. Should I make this bigger? So I can do it like that. Okay, what do you get for the holding period return? Let me see if I can do this alongside. Um, the first time that you do this, a little complicated. Oh, it gets so small. So if I'm going to calculate the holding period with return with this data, I'm going to put 1.0, what am I doing? Yeah, 549 times. So this is the thing. You know what I'm going to do is I'm going to put them in storage. I'm going to do that, store one, because the next one is 1 minus 0.37, right? Because it's 1 plus the return that goes into the factors. But this is 1 minus. So that would be store 2. And then 1.2646 store 3. And then 1.1506 would be store 4. So recall 1, recall 2, recall 3, recall 4. So I'm going to multiply them together now. Recall 1 times recall 2 times recall 3 times recall 4. And then I have to minus the 1, right? No, 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 no. What I have to do now is, um, let's see. So I multiplied them all. I think I got it right, but it looks weird. Let's see. So I multiply them all. Yeah, and I just minus 1. But I feel like I have the wrong number. Oh yeah, there's the numbers. Okay, I'll do it again. I'll do it again. I see what I did wrong. So what did you guys get? Did you finish it? It's hard.
I got if I turn it into percentage, it's negative 3.29,
That's right.
negative 3.3.
That's
That's
right.
wrong.
That's right. I don't know why I'm getting that number. What did I do wrong? All right, so that you got the right answer. Was that Nicholas?
Sebastian.
Sebastian, you're my go-to. You're keeping up here. That's great. Okay. So you multiply them together and minus 1, and you should get 3.3%. What?
Yeah, I did it wrong the first time because the negative I put plus and then negative 0.37. So that's why. But I don't know.
I don't know what
Yeah.
I did wrong, but that's it. It should work.
Professor, did you put did you subtract the 0.37 or did you add it up
I
and
subtracted
that's
it.
why you got
No,
the
I subtracted it. That's exactly why I wanted to show you, because I wanted to show you subtraction. So I did recall 1 was 1.0549. Recall 2 was 1 minus 37. That's it. Recall 3 is, oh, no, no, that's right too. 1.2646. Recall 4 is 1.15. I don't know why it's not working, but it should work, right? Having bad luck this week. I don't know why I get 5. But you guys got it, so very strange. But that's how it works. You just add them together. Okay, it's 63. I had 68. I must have penciled in or keyed in something wrong. Okay, so 1 minus 0.37 is equal to 63 store 2. That'll fix it. So recall 1 times recall 2 times recall 3 times recall 4. I must have pressed the wrong number. And then minus 1 gives me my 3% negative. So I entered something wrong here. Okay, any questions about that? Let's do the geometric average. So how do we take the geometric average now? What we have to do is take that result, add back the 1, and take the root. In this case, there are 4 data points, so it's 1/4 and minus 1. So you're going to take the negative 3.3 is negative 0.0330, put it to the 4th power minus 1. So I'm going to take that. I'm going to add 1. And I'm going to raise it to 4 inverted. And I got it wrong again. So 1 minus, oh, it's probably because of the rounding. Okay, so if you use this value, it's going to be a little bit different. But if you if you just round, so this was just rounded to 3.3%. So let's use that. The rounding is going to make a difference, but you always have to just follow my instructions. In this case, I'm going to use the rounded version. So 1 minus 0.033, and then you raise to 4 inverted, and minus 1 gives you a rounded negative 0.0084 or negative 0.84%. All right, so that means per period or per year in this case, per year, the return was a negative, but not exactly negative 1%, just a little less. So that makes sense, right? If this is a negative return over the 4 years, in answer to my question, it didn't fully recover, right? So if someone invested in 2007 and they left their investment there, over 4 periods, they still lost for every dollar invested. And it's an estimate here of, like, obviously it was very wild. The returns were high, they were low. But on average, this is the estimate of what it was, almost 1% negative. Okay. Now, in contrast, let's just get the average return. Let's put all those numbers together. Don't forget the negative here and divide by 4. And you get 2.5%. Looking at these numbers, which one is more realistic as the return per year?
The GAR.
The GAR. Okay, so when they're different, you go with the GAR. It represents, it's a better representation of what happened. The mean serves a purpose. The mean is used when the data are symmetric. And I explained that in my statistic review video. But when they're not symmetric, you should use the median, or for rates, you should use the GAR. So symmetric, like a bell curve type symmetric. Not exactly normal, but that kind of a shape. All right. Questions about these calculations? So
On an
there are,
unrelated note, is that why people do dollar cost averaging? So they don't, like,
yeah,
if that happens, like that way, if they get in a good time.
yeah. So they're just taking on average, trying to get in exactly, not making time be they're taking advantage of the long game, that eventually the market goes up and they Yeah, they don't care about it. The volatility. Well, this is a very wild time, right? That's not common. But even there, you see that it didn't fully recover, but it's in the end, it's not as bad as it looked. And that's the holding period return over the 4-year period. And this is on average. Okay, so what I just talked about is coming up with an expected value or like a prediction of or an estimate of what the returns were. This data set's returns or in general using the formula, a set of data's return were over a period of time. So using these measures, these statistics of historic or ex post data, this is how you would make those calculations. But in statistics, in the practice, we don't just focus on one number, right? To describe a distribution, you don't just say, oh, well, it was a average of about 1% loss per year. You want to talk about this volatility. You want to talk about the wild behavior, and you use the standard deviation to do that. So just an example of volatility. I don't know if you can see it clearly from where you are, but you guys can look at the notes yourselves. And you see here 3 different assets. You have the more wild, extreme pattern over the 80-year period, 1928 to 2016. So I just have data from a period after the, recovering from the 10-year prior. That's the S&P 500 graph, right? So the bolder. And you see it's much more wild, but also, I mean, they're dips, but they're also peaks, right? And so investing in the risky assets in the stock market, where this is zero, has quite volatile returns. Relative to the others, we're going to see here with the darker dashed line is the 3-month T-bill, and the less dark one is the 10-year Treasury bond. So I've put the darker one. What can you see the difference? Ooh, I should use colors, but people don't print in color, so I didn't put color in these. So which one is the dashed darker one or the lighter dashed one? Which one is more volatile? Which one falls below zero? Can you guys see?
The
So
stock and the bond one.
okay, not
With
this between the not okay, forget about the stock for a moment, just between the T-bill and the Treasury bond, the 10-year bond. So this one is a 10-year bond, much more volatile than the 3-month T-bill, right? It's much more flat. So it's flatter, it's less volatile, it's closer to zero. It's so this one is the less volatile one, the darker one. And it's above zero most of the time. The 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 Treasury bill, the lighter one, kind of falls down and it's more volatile, relatively speaking. All right, so those are 3 asset classes here that you have. The long-term bond, but it's still Treasury bonds. The government bond is government backed, so there is presumably no risk of default. That they will pay investors their coupons, right? Or they'll pay the interest at the maturity, as we discussed bonds. Don't forget what we already learned. And the more risky stock, where S&P 500 is a representation of a set, a diversified portfolio of risky asset in the top performing 500 of them. Okay, so that's volatility. Now, how do we capture a measure of volatility? What do we do? What measure do we use to capture that? What statistic? So we use the mean and the geometric average return to estimate the expected value. How do we estimate variability, uncertainty, volatility? What statistic do we use? Come on, Glenn.
The beta?
Not there yet. No,
No? Oh, okay.
we're not there yet, but we're heading there. Beta is a very specific measure of risk or uncertainty. Variance, right? So here's the variance. We talked about it last few classes. And so we measure it with standard deviation, which is the square root of the variance. And we talked about that as well. So you should be able to make a calculation. Notice this is this finance notation, but this is just the deviation. Oh, the square disappeared. My square disappeared here. Is it gone on your notes? Gee, I have to fix this. Anyway, that's a square there, but you should know that formula. Because we talked about it enough. And the square root of that is the standard deviation. So I'm going to calculate the variance. You guys can do it with your calculator, right? You can get the variance calculation of this data. Why don't you try that? Use your calculator to get me the variance of this data. Remember how to do that? Ex post data. So you go second data, you clear what's in there, you start entering the numbers. So 0.0549, enter down. There's one of those. And it's just for a single data set. So I'm going to skip Y. Then I put in 0.37 negative, enter down, down. And then 0.2646, enter down, down. And 0.1506, enter down, down. And I ask for statistics and go for, well, the mean was 2.5 that we saw in the notes. And then the standard deviation is 27.69. So make sure you can do that. So again, I told you, you're going to be experts in the basic statistics. So I'm giving you a chance to apply that. Okay, so you're going to take the standard deviation of the data. So the thing is, I did it, I calculated step by step here. You should be able to do both, but most of the time you're going to use your calculator, so be good at using your calculator. That's the variance, is 7.67%, but you have to take the square root to get the standard deviation. So that's, what do you think of that standard deviation? Is that high? Is that, what do you think about it? Who thinks it's high? Put it in the chat. Who thinks that's a high standard deviation?
do.
Huh?
I do. Usually it was, well, it is squared, so I guess it could be a little high, but when
Yeah.
I took statistics, it used to be like smaller numbers.
Yeah, right. So this is high, right? This is a high number. It
It
is.
used to be like 3 or 7, not
Right.
27.
Right. 27 is really high, but we already knew that, right? Looking at the data, it was wild. Those returns are wild. Remember. So it's showing what is that standard deviation? It's the square root of the average deviation from the mean. So it's quite wild. All right. So if you guys, in summary, what we got to do with this data, in fact, the data is very wild, so much that we are actually going to use the GAR as an estimate of the average return, or the estimate, yeah, of the average return, as opposed to the arithmetic average return. Similarly, as the mean is affected by extreme values, so would the standard deviation be. So this looks, um, this is not actually, even though we made the calculation, when the data are wild or skewed, not so much wild. When I talk about skewed, and like I say, I made you a set of videos to review statistics to know the difference between these distributions and the results. Let me do that again. This is symmetric. This is skewed. But I only have 4 data points. I don't have a lot of data, okay, to begin with. But when data are symmetric, you use the mean and the standard deviation, and you can use them and assume if you see a certain pattern in the data that is normal. What's a normal distribution? Do you guys remember, or did you review it? So if you see a symmetric
What
distribution,
is even?
what is a normal distribution? How would you describe a normal distribution?
When each subject receives like even values, the same. I thought that
Mm.
was it.
Normal distribution is a distribution that where the data are spread out mostly around the center. How much data is around the center in a normal distribution?
Is it 66%?
Close, close, very good. So 68% is within 1 standard deviation of the mean. What about 2 standard deviations of the mean from the mean? How many observations within 2 standard deviations of the mean? Like a little more wide. You don't remember? This is really important. You need it for this class. 95% of the observations are 2 standard deviations from the mean. And how many are 3 standard deviations from the mean?
It's like 99 point something, right?
99.7. Okay, I see the time is up. Okay, so what you guys need to do is go into my videos and watch the normal distribution topic because you need that for this, okay? You're going to need that. I'm going to ask you to start review 1. This class is ended. You're going to start review 1 and do as much as you can do. You can watch the videos on either the statistic reviews, or you can go into the videos that I have prepared that discuss all this, okay? Basically, you need to know the normal distribution because stock returns, even though over this period and the small data set that I took, doesn't display a normal distribution. In general, stock returns do display normal distributed data over time. And because of that, we can use the normal distribution concept to make predictions. And that's what we're going to talk about next. I wish we could have gotten to it today, but I'm going to ask you to look ahead. There's only a few slides left, and we'll wrap up next week. Okay, so start review 1, start your investigation, remembering what this is, because again, this is not a statistics class. You should know statistics, but I will do this little review with you because you need it. All right. So we'll pick up there next class. Any questions for me?
Yeah, Professor, just to know, can you redo the car calculations because I can't do it on the
Okay,
calculator.
sure. It's important that you can do it. So let's do that. So what I did was, so you guys have to go. Everybody else can go. I'm just going to redo it here. Hold on.
See ya.
Bye. Have a good weekend.
Have a good
Bye.
weekend, everybody.
Thanks. Gracias.
Gracias. All right, so here we are up here. So what I did was I put in the values into memory because they're a little bit wild. So I put in first this 1.0549,
Yeah.
1.0549, store 1, and then 1 minus 0.37, and I stored 2, and then 1.264, oops. See, I did this. I think I did this last time. 2646, and I made a mistake. Store 3 and 1.1506, store 4. So let's review that I did it right. Recall 1, recall 2, recall 3, recall 4. Then I multiply them. And I subtract 1. Can you see
Yeah.
everything? Okay.
Yeah. The question was about the second part, the geometric average return,
Oh, that one?
because
Okay. So then
yeah.
you take that value, you add the
Mhm.
1 back, and then you put it to the power of 1/4. So I'm going to raise, I hit y to the x, and I'm going to put I have to put 1/4. So I put 4 in, and then I invert 4, which is, we know it's 0.25, but I use that symbol. I use 1/x key because I might not get something like 4. What if I got 23 years or 23 periods? How am I going to get the fraction for that? So I invert it and then say equals and -1 to get that result.
Oh, okay, I get it now. I
Okay.
get it.
Yeah. Was it
Yeah,
just
because I was struggling for the
the inverting
for the.
part? Okay. So
Mm-hmm.
y to the x, this key, and this key. Practice with those keys. All right.
All right, perfect. Thank
Okay.
you very much.
Much. Have a good
Good
weekend.
day.
Bye.